powering. So propulsion device. And then next will be propulsion machinery. Propulsion device will be the propeller mainly, and propulsion machinery will be the engine. Ship. So we start with the Reynolds number. So this is two important parameters for resistance and powering is fluid number and Reynolds number. Both are trying to make a non-dimensionalized parameter. Something non-dimensional means it does not depend on any unit, length or time or weight, meter, kilogram, cubic, something. So non-dimensionalized means there is no dimension on this parameter. So it's a complex. Looks like complex dimensions. But anyway, it is in short, it can be used as a dynamic pressure compared to the frictional stress. So on the ship skin, there is a pressure. Pressure is orthogonal to the surface. And pressure is coming from water. And static pressure when the ship is floating. And then pressure is increasing as the depth is increased. So around the whole surface, ship surface, pressure level is different. Deeper position is higher pressure, low pressure. So pressure distribution is all over. And it means it does not say, so there is a static pressure on the surface, but dynamic pressure is when ship is moving or running, moving, running, dynamic motions, the pressure is fluctuating. Or if we are running inside the swimming pool, the pressure is the resistance. So anyway, dynamic pressure depends on time. Dynamic means it depends. There is a parameter time. Static does not have any time dimension. And then frictional stress is a friction on the surface. Friction. So the ratio between pressure, dynamic pressure, and dynamic pressure when we are running, dynamic pressure, and skin friction. Skin friction is depending on the surface area. Frictional stress. So then when we have a number, it has a number, but it doesn't have any dimension or unit. High Reynolds number means a low fraction. This is big, this is small. Friction resistance. And then there will be a vortices in wide range scale. So vortices is coming behind the propeller or behind the ship or behind my body when I is running. Vortex is something like a rotating water. And then rapid change of momentum by vortex. Because of vortices, there is a momentum change around the surface of the ship. And then diffusion means the turbulence is related with the vortices. Vortex and turbulence is related. Turbulence is something like water is running in complex chaos. Turbulence. That gives you energy diffusion. So high Reynolds number gives you many vortex and turbulence you can expect. Oh, there's a video is coming. Wake. This is a laminar flow. The slow speed of water, slow. And then speed is increasing, then vortices is coming, start change, eruption. Still water speed is increasing. And vortex street is coming. This is vortex. and faster, and wider the vortex scale is increasing, and wider spread, bigger vortices, and very high velocities. There's sort of a pattern, but disordered. Water is chaotic, but still there is some kind of the chaotic level is increasing, but still more vortices are coming behind. This is what we call the turbulence. So at the beginning, it was a laminar flow, right? What is flowing slowly, laminar, stable and time invariant. Invariant means no change of shape, right? Straight. So we call it a laminar. And slowly increasing the water velocity at the critical value, then it starts with the film is rotating. And then it comes with the crude number. And then Reynolds number is a two important parameters. If we are talking about hydrodynamics on the ship, and since there's somehow it is saying dynamic pressure and gravity. Previously, it was dynamic pressure. Then what was there? Phenomenon. Friction, something, right? Stress. This one is gravity of the Earth. So high Froude number means lower gravity effect. But it gives you large deformation of free surface. Free surface is between air and water. There is a wave is coming. And effect of static pressure. But it is saying dynamic pressure. So dynamic, static. There are two pressures on the surface. Relatively small for planing and semi-planing. This is a planing ship. Planing means something like a water ski. Right? So when ship is staying no speed, water level is higher up to here. Water level is higher up to here. When ship is staying, no speed. But if the speed is going up and up, then have you tried water ski yourself? Nobody. So when you start the water ski, you need to hold tight on your line. The boat is going yourself, but your body is submerged. Okay? Then, so at the starting point is very tough for every water skier. Once there is a speed, then the ski gives you lift, something like an airplane lift. Then your body is over the water. Same as this one. When the ship is higher speed, the ship is lifting up because of some kind of dynamic pressure. We call this is a planing. So this kind of ship we call the planing ship. Water skiing ship. Is it going up? Anyway, Froude number, so high Reynolds number also gives you higher speed of the ship. High Froude number also gives you higher speed of the ship. Both are same, but the related phenomena is different. So they try to separate out the terms of the resistance and powering, terms of the equation, into which one is more dependent on Reynolds number and which one is a bit more related to Froude number. That's why they are using two different parameters from the history of your research and resistance. Oh, there is another video. Subcritical flow, hydraulic jump, supercritical. So here is some kind of dam over there, right? This is something like a dam. Water is flowing from here. Water level is here. So water is like this one. Touching, this is just touching. So they are trying to show you a hydraulic jump there and super critical. So video, same video is running again and again. So trying to explain the fluid number effect and then high speed of the wave is generated. And then propulsion devices. Screw propellers is the most typical one. And screw propellers' basic function is to convert torsional energy coming from the engine into the thrust. Thrust means you push the ship, right? by using propeller. The ship is pushed to get the speed. Each blade of the propeller, this is blade section of this one propeller. If you cut down the blade into section, then you can see this is an airfoil section, same as the airplane. But this propeller blade is complicated. Three-dimensional rotational motions, shape. Anyway, the propeller slides the water and it imparts the backward thrust. The thrust is coming in this way, same as the airplane wing, right? Because of the speed change difference between back and up, front, or above and down. Speed is higher here, so the pressure level is lower here. There's total integration of pressure around the surface skin, and net force is coming into lift or thrust. So altogether, and you see the size of the propeller comparing to the size of the human body. So it's very big, right? How big is it? Let's say this is 2, then it can be 10, 5 times of 2, 10 meter or more diameter. And number of blade is 6 here. So how can you design the propeller? As a engineer or naval architecture, you need to design that kind of propeller by using equations. You should know how many blades, how many skew. It is skew. We call it skew. Is it good or not to have a skew? So propeller related terms, there are also complicated terminology there. Suction and pressure side. Suction side is less pressure, right? Suction side. And pressure side is higher pressure. So net will be lift, right? Or the suction. Okay, so and then leading and trailing edge. This is a propeller is rotating in this way. So this is a leading edge. Water is cut by this leading edge, and this is a trailing edge, following the leading edge. If you think about wind power blade, leading edge and trailing edge, and hub is this one is hub of the propeller hub, and root and tip. So root can be around here. So it says blade root, and this is hub, blade root. Just neighborhood, and then blade, and say trailing edge, and then can be a leading edge in here, leading edge here, leading edge, leading edge, leading edge. And blade tip, blade tip, blade tip. And diameter is this one, diameter. And pitch, slit, skew, rake. Pitch can be the angle vortex. So wind power system is something same as wind blower. 선풍기가 뭐는 뭡니까? 선풍기. wind blower. 가전제품 선풍기. In home and somewhere you need to have a fan, wind fan. That has a skew, angular vortex. That is we call the pitch. Pitch is same as a bolt and nut. One rotation, how much they advance, we call this pitch. Probability, rotative circle, skew and rake is not shown here. No, skew is in this way. Skew. But this propeller does not have. Oh, this one is. So then, if rotating this way ahead, right, and rotating this way, we call this leading edge, trailing edge, and then this one it shows a middle line along the blade. So that amount is we call skew. And if you cut the section in this way somewhere, then you will see this is an arrow. Yes, and then yes. So as a designer, you need to make this kind of drawing for manufacturing of the propeller. So this gives you a very detailed shape of the one blade. The other one is same, right? And then pitch will be in this way, transverse view and profile view, side view, and each line is. And pitch distribution, interesting. Not explained. So type of screw propellers. There is a solid propeller or something like a fixed pitch propeller. Then there is another one, is a controllable pitch propeller. This one looks like a controllable pitch propeller. Here. There is something like a bolting here, so that the whole circle or cylinder can be rotated. The whole blade can be rotated. By rotating this way, you can change the angular vortex. We call this is a controllable pitch. So the captain can change the angular vortex by using some device. And then supercavitating propeller looks like this. So they have, this one always has a cavitation, full of cavitation. Cavitation is not good, right? Why not good? Why? What's the answer?
You make noise.
Noise.
And it
Efficiency can be dropped down.
Yeah.
And noise is coming from what? Where? Bubble collapse. Not bubble generation. When once generated and then collapse, it gives you very big sound. It's something like a hammering sound. Yes, hammering sound. So supercavitating, they do not allow collapsing of the bubble. They just generate bubble, and bubble is going away. That is the idea behind the supercavity. The advantage of this one, it can give you very high speed. Although the efficiency is low compared to the commercial low speed one, but for the Navy ship, Navy ship, they want to have a higher ship than compared to the enemy ship as well. So instead of, although the efficiency of propeller is low, they want to get higher speed to win the battle. That is the idea. Right? And counter-rotating propeller means here. Right? There's a two propellers running together, right? But their rotational direction is different. Against, we call this counter-rotating. It's counter. Education. Key practices. Local pressure is low. This is a bubbles coming from the propeller tip. This is a propeller blade that is rotating, and the suction side, the pressure is low, so that there's a bubbles generated. I guess there will be another view. And if you see the front view, then the area of the bubble generation is changing because this is rotating. Right. Okay. So control over pitch propeller.
We have crossed into a new world.
Massive ships are powered by massive propellers. Likewise, small boats are powered by small propellers, but the principles are the same. One propeller is the controllable, variable propeller. But how exactly does it work? This vessel is the Hermes. She's an old design deep-sea salvage tug fitted with two propellers. I don't know what her original propulsion was, but I can use her for this demonstration and give her one controllable pitch propeller and one fixed pitch propeller. When they're spinning away like this, it's hard to see anything much, so let's slow it down and look at the controllable pitch. Like this, she's running ahead. the propeller blade is cutting the water and propelling it backwards. This is no different to a fixed propeller. When running ahead, they look exactly the same. The difference comes when we want to reduce the speed. To reduce the speed of a fixed propeller, you have to slow the rotation. Very easy if you've either got a gearbox or an engine that can easily vary its speed. It's a bit harder when your engine likes to run at a constant speed. A controllable pitch propeller, on the other hand, runs at a constant rotational speed. To reduce the vessel's speed, you change the angle of attack of each blade instead. It's hard to see while rotating, so let's stop it and have a closer look. Running ahead, you can see it's got a steep angle
Rotate
of
this
attack.
whole
This makes it harder to turn, but generates more thrust. As you reduce the angle of attack, the engine has an easier time turning the propeller, but it generates less thrust, slowing the vessel. You can generate zero thrust by setting the pitch to zero. For example, this setting would be used when a ship has started her engines but is still alongside her berth, not yet wanting to move. By contrast, to set a fixed pitch propeller to generate zero thrust, literally stop it. For a stern propulsion, the propeller needs to turn in the opposite direction. Ships do this either through a gearbox arrangement or sometimes by literally stopping the engine and restarting it in the other direction. The controllable pitch propeller just needs to alter its pitch to be pointing the other way. If we stop it again, you can see the alteration becomes a lot clearer. The shallow angle generates lesser stern thrust, but you can increase it by altering the blades even further. One thing to just compare quickly is the path that the water is directed down.
All right.
Going astern, you can see the shape of the
So this one is used for use when the ship is in slow speed. This is contra-rotating propulsion. This is air propeller, not water propeller. So that gives you more even. That gives you the focus there. See? Right. Cavitation and erosion, on the other see, low speed increase low pressure and suction side. Suction side is this way, is this part. Water comes to boiling. Boiling is generating cavity, air bubble, even in a low temperature, not high temperature. We boiling water is 100 temperature centigrade, but in higher region Himalaya, you see boiling in low temperature. And it happens cavity in a pump or in a propeller blade, and also hydrofoil. So that the erosion, the metal is eroded in this tip blade because of this kind of cavitation collapsing. Okay. Question. No. Right, then we can move on to model test by no.
I sent you the
All right.